In PLC programming, you've got tools that save you a few seconds, and then you have tools that completely change how you write your code. Today, we are diving deep into one of those game changers, the powerful, super efficient, and sometimes misunderstood file fill instruction. You know it as FLL. So here's what we're going to cover. First, we'll set the stage with a really common, tedious problem you've definitely run into. Then we'll bring in the FLL instruction as the perfect solution, see how it works in the real world, cover the super important safety rules, and then wrap it all up with the one key takeaway you need to remember. All right, let's get into it. To really understand why the FLL instruction is such a big deal, you first have to appreciate the kind of headache it was designed to fix. Okay, picture this. Your machine keeps a history of the last 50 alarm codes in an array. The operator hits the Clear Alarm History button on the HMI. Now it's your job to write the logic that takes all 50 of those values and resets them to 0. What's the first thing that pops into your head? Well, you could do this. You could write a separate move instruction for every single element. It'll work, for sure. But wow, is it tedious to type out? It makes your code super long and clunky, and it's just inefficient. There has to be a better way, right? And you know what? There absolutely is. So let's meet the star of today's explainer, the FLL instruction. Think of it as the perfect power tool for exactly this kind of bulk data job. At its heart, the FLL is just beautifully simple. It's an instruction designed to take one value, just one, and paint it across an entire block of memory, like an array. It's like taking a paint roller to a wall instead of using a tiny little brush. And here's the real magic. The moment that rung of logic goes true, the FLL instruction grabs your source value, and in one single lightning-fast processor scan, it fills the entire block. It's not a loop that has to run 50 times. It's one efficient operation. Bam, done. And all that power is controlled by just 3 simple things you have to tell it. You give it the what, that's the source value. You tell it where, that's the destination, the starting point of your array. And you tell it how many, that's the length. That's it. Simple, clean, and incredibly powerful. Okay, theory is great, but let's see this thing in action. We're going to go right back to that alarm reset problem and see how FLL completely transforms our code from a mess into something beautiful. Remember that big, ugly block of 50 separate move instructions? We can just get rid of all of it. The FLL instruction replaces every single one of those lines, all of them, with just one elegant command. So for our alarm problem, it looks like this. Our source is 0, our destination is the starting point, alarm code 0, and our length is 50. It's that simple. One instruction now does the work of 50. And this is where it gets really good, because the benefits here are just huge, and they go way beyond just saving you some typing. The bottom line is this: you write your code way faster. The PLC itself runs it more efficiently because it's a single optimized operation, and your logic becomes crystal clear. Anyone else who looks at your code immediately knows, okay, the goal here is to wipe this data array clean. And this isn't just for alarms, not by a long shot. This is an incredibly versatile tool. Think about starting a new batch on a production line and needing to zero out all your calculation tags, or clearing old recipe data before loading in a new one. Anytime you need to hit the reset button on a big chunk of data, FLL is your best friend. But hey, just like any power tool, FLL can be dangerous if you don't use it correctly. You can make a real mess if you're not careful, so knowing its limitations is just as important as knowing its strengths. Okay, listen up, because this is the big one. There is one mistake you can make with the FLL that is a programmer's nightmare. It can cause these bizarre, unpredictable problems that are incredibly hard to track down. Let that sink in. If your array is, say, 50 elements long, but you accidentally tell the FLL to fill a length of 60, it won't stop. It will just keep on writing past the end of your array, stomping on whatever data happens to be next in the controller's memory. And the worst part? The PLC might not even give you an error. So, rule number 1. This is the golden rule of FLL. Always, always, always double-check that your length parameter is not bigger than the actual size of your array. This is absolutely non-negotiable. Another really key point is knowing what FLL can't do. It's a one-trick pony. It only works with a single source value. If you need to copy a whole bunch of different values from one array to another, like loading a recipe with multiple steps, that's a different job. For that, you need a different tool, like the copy file or COP instruction. And there are a few other little gotchas to keep in mind. It generally works on word-level data, so you can't use it directly on an array of Booleans. Your data needs to be in one continuous block of memory. And, well, you can use it with more complex data types, but you have to be really, really careful. So after all that, the good, the bad, and the dangerous, what's the one thing you absolutely have to walk away with? What's the main idea? The most important thing is to think of the FLL instruction as a specialist. It is not a Swiss Army knife. It's a highly optimized tool designed to do one job and do it incredibly well: bulk data initialization. So the rule of thumb is really simple. Use FLL when you need to zero out an array or wipe a block of data clean for a fresh start. Don't use it when you need to copy complex patterns or move a bunch of different values around. For those jobs, you've got other tools, like COP, that are a much better fit. Which really brings us to this final thought. The FLL is an absolute master of the bulk fill. But being a great programmer is about knowing your entire toolbox. Understanding when to pull out a specialized tool like FLL and when to reach for something else is what really takes your code to the next level.